Okay, welcome to the triangle method for formula rearrangement. This is a very brief PowerPoint. I'm actually going to use a PowerPoint interactively, and we're going to talk about how to rearrange formulas. Now, if you guys are familiar with basic math from high school and you're comfortable with that, then this will probably be unnecessary, but I'm going to teach it anyway because it's a quick way to check to make sure you applied the right change to the formula. It's called the triangle method. It lets me rearrange a formula to get the answer for something that wasn't in the answer side of the original formula. So let me click on to the next slide. So here's my triangle, and you can scribble this triangle really quick on the corner of your paper. It's a great way of quickly diagramming formulas. So the formulas I'm going to use are all your most common formulas in the mechatronics world. And voltage, V equals IR, should be a formula you have memorized. Power equals IV is probably even more important. Power is equal to the current times the voltage. V equals IR means the voltage is equal to the current times the resistance. These are two very, very basic formulas, and I use them often even in the real world. Now in the pressure world, you have to calculate force that's created by compressed air or compressed anything with anything under pressure is equal to the pressure times the area. Torque is equal to the force times the length of the lever arm. So if I'm torquing a bolt, I measure that based on the force that I'm applying on the leather arm and then the distance of that ratchet arm or giant pipe I stuck my ratchet into, which is how you crack bolts or hurt your knuckles, one or the other. And then and the last formula I'm going to use is area of a circle, which is equal to A equals pi r squared. So that's pi times the radius of the circle squared. So we're going to dive into how to do that. So there's two steps to figuring out how to apply the formula. The first step is load your formula into your triangle. And so I'm going to do that very quickly. So the formula I'm going to load in first is V equals IR. You always load the V side, or the side that you're solving for, or the side where you have a single variable, load that into the top of the formula. So I'll just type in V. And you load the other side, the side where you've got two things multiplied by each other, or the thing you're using to calculate what you solve for, into the bottom of the triangle, I and R. Okay, now you've got your formula. Boom. I can do the same thing for power. P is equal to I times V. Boom. Now I've got that one done. Same thing for force. I'm not going to do it again. That's kind of obvious. Same thing for torque. Do it again. Same thing for area. A is equal to pi, and rather than getting that symbol, I'm just going to type pi, r squared, r squared. But I got to use a superscript, so that takes me an extra second to convert that to superscript. So there, I've got area over pi and r squared. So that's my formula all set up. So that's the first step. You load the formula into the triangle. Now, the second step is figure out what you want to solve for. Once you've loaded into this triangle, you can solve for any one of those three variables. So the obvious one is P, right? You've used that formula that you came up with to load this triangle. So if you solve for P, but you really don't care about it, how you solve for anything is you cover up with your thumb, with a little circle like this, you cover up what you want to solve for. So we know this triangle is working because I cover up P, and I'm left with I times V. So the fact that these are in the bottom of the triangle right next to each other means I multiply them by each other. So P equals IV. So I've just verified that my triangle works. Now what if I want to solve for the voltage? Let's say I know what the current is running through the light bulb. I know what the power of the light bulb is, but now I want to solve for the voltage. Well, then I just cover up the voltage. And I get P over I. P, so if I'm solving for voltage, then my result is P over I. P divided by I. So my formula now is V equals pi divided by, or I'm sorry, power divided by current. So V was voltage is equal to power divided by current. So that's how I can solve for that. What if I want to solve for current? I know what the voltage is. It's a 120 volt AC circuit. I know I have a 100 watt power, 100 watt light bulb. Then I just cover up my I. And now I see that current is equal to power divided by voltage. So I can type that out. Power divided by voltage. So there I can see power is divided by voltage. So simple, right? Easy way to check to make sure you've divided or multiplied by the right thing. It's quick to little scribble out that triangle. It's quick to use it. So it's a very nice method to check yourself, to remember if you've done this right. So let's try another example. Let's use the torque example. So if we switch, let's move my little covering bubble over. Let's switch this torque is equal to FL. So don't forget, the T goes on the top, and then the other side of the formula goes on the bottom. FL. So if I want to solve for torque, I know that F is multiplied by L. If I want to solve for the length, and I know the torque, I can say the torque, the length, is equal to the torque divided by the force, because T is over F. So torque divided by the force. So my resultant formula is the length, the lever arm in inches or pounds, depending on my unit of measure. So I still need to make sure I document my unit of measure to get the right answer. But the length is equal to the torque divided by force. Last but not least, let's go into my area. If I want to solve for area, I do the pi r squared. I'm just going to type out pi here. And then let's move my little cover. Let's do the r squared. And do my little superscript here. Come on, let me select that. There you go. It's font, superscript. Okay. Okay, so now I've got pi equals r squared. So now I can solve easily. If I want to solve for r squared, I can get the area divided by pi. And I need to adjust my, so r squared, let me just change that to superscript, is equal to area divided by pi. But guess what? This doesn't tell me what the radius is. It shows me what the radius squares is. So now let's go to the last part of this lesson, which is how you get to the final radius. If you've got a squared kind of situation for any part of your formula, then you're going to have to apply a square root to that square, because to get rid of a square, you square root it. And I can't just square root one side, I got to square root both sides, because the way math works is if you apply the same function to both sides, both complete sides of that formula, then that formula remains good. You can still use it. So if I'm stuck with pi, r squared is equal to a divided by pi, I need to apply the square root to both sides. So there's my formula. So I apply square root to both sides, and there's my square root function. The square root of r squared is simply r. So the square root of a divided by pi, I can use a calculator for. So my resultant formula looks like this. R is equal to the square root of the area divided by pi. And that's a rule of all math. You got to apply the same function to the complete side of each side of a formula. And if you do that, your formula remains good. You can continue to use that. That's pretty much the entire lesson for today. I'm going to open this up